explaining how charges forms, we have the law of charges. The law of charges says that unlike charges, while like charges, you know why you are sitting between these two girls? Do you know why? Because they are the unlike charges. Unlike charges attracts, while like charges repels. That is the law of charges. So 2 positive charges repels, 2 negative charges repels. Now a positive and a negative charge attracts each other. Even in electrical wire connection. Do you understand? If you want to connect wires, you connect positive end to negative end. If you connect positive, the wire will jam. That will be a very big spark. That will be a very big spark. So we connect positive to negative. That is the law of charges. Now there is what you call the gold leaf electroscope. A gold leaf electroscope is a device, a gold leaf electroscope. A gold leaf electroscope is a device for testing charges. It is a device for testing electrical charges. Diagrammatically, we can represent it in this form. Has a cap, a rod, now we have the gold leaf. We have a cork. We call it an insulating cork. Now a glass casing. Around the glass casing, we have the meter. The metal cap, the glass casing, the meter, we have the gold leaf. And this is the insulating cork. The insulating cork must make sure that the casing is not touching the metal rod. That's why we call it an insulating cork. Insulating cork. Remember that materials are divided into 3. I hope you know. One is if it can conduct electricity. 2, if it cannot conduct electricity. 3, if it may conduct electricity. Are you hearing what I'm saying? Materials are divided into 3. The first one is if it can conduct electricity. What will we call that material? It's called a conductor. Now, if it cannot conduct electricity, what do we call it? It's called an insulator. Now, if it may conduct electricity, what do we call it? We call it semiconductor. Can you give me examples of a semiconductor here? 1, silicon. Number 2, gallium. Number 3, arsenide. Number 4, you say what? Boron. Number 5, please write it down. Examples of semiconductors: we have silicon, we have gallium, we have arsenide, we have boron. Please write it down. Very, very important. Now, what is the major difference between a conductor and a semiconductor? Can somebody help us out? I will give you 500. What is the major difference between a conductor and a semiconductor? If you get it correctly, I will give you 500. I'm serious. Please listen. Listen. She said something. She said that the conductivity of a conductor decreases with increase in temperature, while the conductivity of a semiconductor increases with increase in temperature. Is that correct? You say the conductivity of a semiconductor increases with increase in temperature, while the conductivity of a conductor decreases. Okay, increases with decrease in temperature. Is she correct? Okay, give us your own answer. You say what? Yes. It's the resistivity of a semiconductor with increase in temperature. Well, 2 of you saying the same thing. Yeah? You said no. Do you know that is what we call, please. She said something. Now, she said that the conductivity of a conductor decreases with increase in temperature. Now, you said that the resistivity of a conductor, you say, increases with increase in temperature. Is that what you say? They are the same thing now. And you said no. Open a class can get them PIG 6. Or we never lesson center. Well, 2 of them, they are correct. Put your hands together for them. But I will give the girl 500 because she was the first person to. Now, please, I need the change. I need 500. Please get 500 for me. Two 500. You are just giving me one. Okay, sir, man. Wait. Okay. Now, the temperature difference is the measure difference between a conductor and a semiconductor correlations. Now, a semiconductor conducts at increase in temperature. A semiconductor, please write it down, is a constant question in JAMB. A semiconductor conducts at increase in temperature. So, in a reduced temperature, a semiconductor is an insulator. In a reduced temperature, a semiconductor is an insulator. But once the temperature increases, a semiconductor starts to conduct perfectly. Conduct even up to superconductivity. I repeat again. I say that a semiconductor at a reduced temperature is an insulator. A semiconductor at a reduced temperature is an insulator. Now, if the temperature increases, a semiconductor begins to conduct even up to superconductivity. Even up to superconductivity. A semiconductor starts to conduct at increased temperature, even up to superconductivity. Now, back to the gold leaf electroscope. Back to gold leaf electroscope. Gold leaf electroscope now, in charging a gold leaf electroscope, either we use the contact or induction. Please, is a very big point. One, contact or by induction. I will explain all these things. Now, I have seen some textbook that will tell you that gold leaf electroscope is charged by induction. Please, gold leaf electroscope can also be charged by contact. So either you use contact or you use induction. Now, how do we charge a gold leaf electroscope? We'll follow these steps. What will come in your mind is, do I want to charge it positively or do I want to charge it negatively? That's the first question that will come in your mind. Am I charging this gold leaf positively? Am I charging the gold leaf negatively? Supposing we want to charge a gold leaf electroscope positively. You bring a negatively charged body in contact or near the cap of the gold leaf. So if I'll bring a negatively charged body, because I had the intention of charging it positively. Now this is a negatively charged body. Now I'm bringing the negatively charged body. The positive charges will come close to the cap, marking attraction, while the negative will move down near the leaf, indicating repulsion. At this moment, the leaf diverges. The leaf diverges, indicating the presence of a charge. Do you have any question? You say what? Okay. I said they leave. Which one is that? Please, somebody should stand up and speak. Number one, bring a negatively charged body in contact or near the cap of the gold leaf. We say the leaf diverges. Once you bring it close, the leaf diverges. Yes. Yes, I say if you want to charge the body positively. Yes. Yes. So she was asking, which steps are we taking? I said, if you want to charge a gold leaf positively, if you want to charge an electroscope positively, the first step is to bring a negatively charged body in contact or near the cap of the gold leaf. I'm now to explain to you what exactly happened. When you bring that, the positive charges, remember, the gold leaf initially is neutral. The gold leaf is neutral. So if you bring that negatively charged body, the positive charges will come up to the cap, indicating attraction. Indicating attraction, while the negative charges will move down towards the leaf, indicating repulsion. Now, at this instant, the leaf will diverge, showing the presence of charge. The leaf will diverge, showing the presence of charge. The second step is to earth the gold leaf. You earth the gold leaf. Earthing the gold leaf means connecting a wire from the ground to touch the electroscope. Connecting a wire from the ground to touch the electroscope. Now the electron will now flow to the ground. the electron will flow to the ground. If you eat the gold leaf, while the body, the charging body is still here. Remember, you have not removed the charging body. The charging body is still in contact or near the cap of the gold leaf. You touch this with a wire to the ground. Now, electrons will flow to the ground. Remember, I told you that the proton don't move. Please mark that. It's very, very important for your jam questions. What moves is the electron. Electron can come up from the ground to neutralize the proton. Electron will flow from the body to the ground. But the protons is always static because of their heaviness. Because of their heaviness.